Authentication tells us who is calling. Authorization decides what that caller may do. In this module, we'll connect scopes, roles, tenant boundaries, and policy engines, so MCP tools and backend services enforce least privilege in production. So far, we've moved from MCP foundations into security thinking. You've seen how production MCP servers are structured and how threats can appear across tools, prompts, resources, users, clients, and backends. Authentication answered, "Who is this?" Now, authorization answers, "What are they allowed to do?" That is where least privilege becomes practical. Authentication and authorization are closely related, but they answer different security questions. Authentication confirms the caller's identity, the user, client, service, or session reaching the MCP server. Authorization comes after that. It decides whether the verified caller can use a tool, read a resource, or trigger a backend action right now. In production, every sensitive invocation needs this second check. The guiding rule is least privilege. Grant only the access needed for the current user, tenant, client, and task, and deny everything else. MCP authorization works best as a chain of decisions, not one gate at the server. Start with discovery. Tools, prompts, and resources should be visible only when they fit the user's context. When a tool is called, check both the caller and the specific arguments. Then carry identity and policy into downstream systems, because backend permissions still matter. Before returning the result, inspect the output as well. Sensitive fields may need filtering, redaction, or denial. Strong MCP security enforces policy at every boundary. A strong authorization decision is built from several signals. It starts with who is calling, a user, service, organization, session, or client app. Then it considers broad permissions, such as scopes and roles. Product rules also matter, including plan entitlements and enabled features. Context adds another layer. Tenant membership, resource ownership, data sensitivity, location, time, and environment. Finally, the backend must still be able to enforce the access. Combined well, these signals make authorization precise, explainable, and harder to bypass. Treat each MCP tool as a protected capability. Before a user can discover it, check role, scope, tenant membership, and entitlement. Before it runs, check again against the requested arguments and the backend action it would trigger. Visibility is not the same as permission to execute. A user may be allowed to know a tool exists, but not call it with sensitive parameters. If identity, scope, tenant, entitlement, or backend permission is missing or unclear, fail closed. Ambiguity should result in denial, not a best effort action. Good MCP scopes describe real business capabilities, not internal shortcuts. A tool that reads orders should use orders. Read, not admin. A tool that updates orders should use orders. Update, not all access. This action resource pattern keeps permissions understandable, auditable, and easier to review. Separate sensitive actions like delete, export, impersonate, and administer because each carries a different risk. Broad scopes are sometimes necessary, but treat them as exceptions. Tightly approved, logged, and monitored. The goal is access that matches exactly what the tool must do. Roles, scopes, and entitlements each answer a different question. A role says who the person is in the organization, such as support agent or billing admin. A scope says what this token or session is allowed to do, such as read tickets or call an API. An entitlement says what the customer or account has purchased or enabled, such as pro features. In real systems, access usually depends on all of them. The right user, using the right token, inside the right tenant, with the right product capability. Authorization should not happen only at login. In an MCP server, each stage needs its own decision. During discovery, show only the tools that fit the user's tenant, environment, and policy context. Before execution, verify scopes, roles, entitlements, tenant membership, and argument permissions. Before touching backend systems, recheck against the system of record, because access may have changed. And before sending the response, confirm the user can see the result. Redact fields they cannot access or deny the result if it is too sensitive. Dynamic tool availability is like giving each caller a toolbox that matches their context. A basic user may never see administrative or restricted tools, which reduces confusion and accidental misuse. tenant, environment, and plan can filter the catalog further. So staging, production, free plans, and enterprise plans expose different options. For sensitive tools, the server can add annotations such as warnings, quota limits, or conditions the model should consider. Just keep the distinction clear. Visibility guides behavior, but it is not security by itself. Every tool call still needs authorization when it executes. Tool metadata should guide safe client behavior, not replace enforcement. A description can explain what the tool does and include user-facing constraints such as read-only, requires approval, risk level, or required scopes. Avoid exposing hidden roles, internal policy rules, or logic an attacker could exploit. Treat fields like required scopes as signals for the client experience. The MCP server must still check identity, permissions, approval state, and request context before executing. Helpful metadata improves usability. Server-side validation remains the security boundary. As MCP deployments grow, authorization rules should not be scattered through server code. A stronger pattern is for the server to gather the facts: who is calling, what action they want, which resource is involved, and what runtime context applies. It sends those facts to a policy engine, which evaluates standardized rules and returns a clear decision: allow or deny, plus a reason and any obligations. The server still enforces the result locally, but the logic becomes centralized, testable, and reviewable. Tools like OPA, Cedar-style policies, or policy-as-code workflows all support this model. Attribute-based access control moves beyond simple roles. Instead of asking only, "Is this user support?" it asks, "What is the user's role? Which tenant are they in? What ticket are they reading? What region is assigned? And what is happening right now?" That supports decisions like allow ticket, read only when the agent belongs to the tenant and the ticket's region is assigned to them. Policy as code treats that rule like software. It can be reviewed, tested with allow and deny cases, versioned, and rolled back. Keep policies small, clearly named, and covered by tests. Authorization is not finished when the policy compiles. You need evidence that it behaves correctly in production. Test the happy path, but also denials, boundary cases, cross-tenant access, and privilege escalation attempts. When a decision is made, log enough to explain it: subject, action, resource, tenant, reason code, and policy version. But do not turn logs into a data leak. Exclude tokens, secrets, full prompts, and unnecessary personal data. Track deny rates, latency, and missing context. And choose safe failure. If identity, tenant, policy, or backend checks cannot be verified, sensitive actions should be denied. Authorization is the control plane for safe MCP tool use. Protect every sensitive tool, backend action, resource, and output path. Combine roles, scopes, entitlements, tenant membership, and attributes to enforce least privilege. Dynamic availability helps users see relevant tools, but policy must still be enforced at execution time. Next, we extend this foundation into delegation, isolation, secrets, tokens, and auditability.